Welcome. Now we are going to be discussing the present value, and we have seen the future values and examples as well. So if you haven't checked that out, I would advise you that you watch the previous videos that we have. All right. So what is the present value? Present value is what your investment is worth today, and it's done through discounting process. So as mentioned in the definition that we said that present value is what your investment will be worth today. And this is the formula that we'll be using for the present value. So present value is equals to future value divided by 1 plus r raised to power t. So this is discounting itself. You discount the future value or the amount that you're expecting in the future back to a time today, or back to t is equals to 0. Let's see some examples of present values. If you were to receive $100 5 years from now, how much is that amount worth today if the interest rate is 12%? Let's say your uncle has promised you that in 5 years' time, he will give you like $100, and the interest rate at the moment is 12%, and you're required to find the present value of that amount that you are to receive 5 years from today. So how much is that money worth today? That's what the question is asking you to find. Let's do that. So in the solutions, the first step that you want to do is to identify main points. So here, the main points we identify here are in regards to the formula that we have here for finding the present value. So we'll identify the items in the present value and then see the amount that corresponds to each of them. So the future value, or the FV, the amount of money that you're expecting in the future, is $100 in this example. So $100 because you're to receive $100 5 years from now. The R, or the interest rate, is 12%, or 0.12 as a decimal, and time, or the duration of the investment, is 5 years. Secondly, since the question is asking how much it will be worth today, we are using the present value formula. So that gives you a clue that we will be using present value because it's asking you how much is that amount worth today. So worth today is is one of the main points that we have here, or the determinant that shows you like what are we going to use? Are we going to use the future value formula, or are we going to use the present value formula? So in this case, we're using the present value formula. So PV, the present value, is equals to FV, or amount that you're expecting to have in the future, or a future value, divide by 1 plus R raised to power T. So you know what R and T means. R is the interest rate and T is the duration of the investment. So PV is what we're looking for here, or what the question is asking you to find, is equals to FV. FV is the future value, 100. We already identified that here at the main point. So FV is 100, divided by 1 is a constant, it doesn't change, plus 0.12, which is the rate. Here we have 12%, so R is 0.12. Then you raise to power 5. 5 is the T, of 5 years. All right, so now that we've plugged in the numbers, step 2 is to calculate. So I do encourage students, and I say this even in the previous examples with the future values, that you always start with what's in the parentheses. So in your calculation, start with what's in the small parentheses. And here, what we have in the parentheses is 1 plus 0.12. So that would be 1 plus 0.12 is 1.12. And raise 1.12 to the power of 5, because 5 is the T. So we have that exponential here. So we have like the 5. So 1 plus 0.12 raised to power 5. And that yields 1.7623. The last thing is to divide 100, because here in using the future value, we do multiply PV times the rate. So if you're not familiar with that, you can check the previous video that I made about future values with examples and step-by-step solutions to that. So here we have 100. We divide by what the answer that we found here. So divide 100 by your answer above. So 100 divided by 1.7623, and you get 56.7427. So this is the final answer, or this is the amount of money. I mean, that is how much $100 that you are promised 5 years today, 5 years from today, like that is how much that money would be worth if you were to be given that money today. So the $100 that you will receive in 5 years time is worth 56.74 today. So that is the answer. All right, so let's cover the second example. Brianna is expecting the following cash flows from a project she is considering. She's expecting to get 50,000 at the end of the first year, so 50,000 at the end of year one, excuse me, 80,000 at the end of year two, 90,000 at the end of year three. What is the amount Brianna can pay today for this project and still earn her required return of 14%? So this is a little bit more complicated, but don't worry. I got you. We're gonna get through it successfully. Okay, so Brianna is expecting these cash flows: 50,000 at the end of year one, 80,000 at the end of year two, 90,000 at the end of year three. So what is the amount she is expecting to pay today if she wants to still earn her required return of 14%? So how do we answer this question? So the first thing, as obvious, definitely, I'm sure probably you guessed it right, is to identify the main points. And here we have three future cash flows. So keep that in mind. We have three future cash flows at year one, two, and three. So we will be labeling these individual cash flows as FV1, or the future value or an amount that is expected at the end of year one. So it's 50,000. FV2 is 80,000 because that is the amount that is expected at the end of year two. And then lastly is FV3, or future value three, which is 90,000. Since the question is asking how much she can pay today, that gives you a clue that we are going to be using the present value formula. Excuse me. Yeah, because that is the question is asking how much can she pay today. So we are using the present value formula. The second step is, remember that we find the present value of each cash flow individually and we add them up later. So the first thing is to find the present value of each of the FVs. So here is the overall present value that we're looking for is equals to FV1. FV1 is the cash flow that is expected at the end of year one, or at the end of t is equals to 1. So FV1, we identified FV1 here as 50,000. That would be 50,000 divide by, because we're doing this counting process when we're finding the present value. So 50,000 divided by 1 plus 0.14 is the interest rate that we have right here. The required return is 14%. So that is the interest rate. And we'll be using the same interest rate for all of these cash flows. So here it's 1 plus 0.14 raised to power 1, because it's at the end of year one. So we are discounting only by one period, plus 80,000, the cash flow is expected at the end of year two, or FV2, divide by 1 plus 0.14, the interest rate, raised to power 2, because we are discounting by two periods, because this is the cash flow at the end of year two. Lastly, we have 90,000. We discount it back by three periods by dividing it by 1 plus 0.14 raised to power 3. So all these will yield 43. The first cash flow, the present value of the first cash flow will be 43,859.649. The second cash flow is 61,557.402, and the third cash flow is 67,47.436. So that's why we say that after finding the present values of these cash flows individually, we sum them up. So summing them up will give us the overall present values of all these cash flows, and that would be 166,164.48. So this person will pay. Brianna would pay $166,164.48 today if she is expecting to earn her required return of 14%. So thank you very much for your time. I hope you got much benefit from all these examples. And good luck with everything to do with present values and future values as well.